Hello, my name is Ben Crabb. I do technical sales and support here at Apogee Instruments. I'm here today to talk to you about a set of new coefficients that we have for our MC100 chlorophyll concentration meter. We actually have two new species that we can measure accurately, cannabis and grapes. And so I'll briefly go over how this meter takes measurements of absolute chlorophyll concentration, and then we'll go into how to get those new coefficients, select them, and start taking measurements. So very briefly, the operation of this meter is based on the transmittance of light at red and near-infrared wavelengths through a plant leaf. This item has two LEDs in it, one of which emits light in a red wavelength of 653 nanometers. The other one emits light at a near-infrared wavelength of 931 nanometers. Now the red wavelength, plants can use that type of light for photosynthesis, and so most of that light gets absorbed and used by the leaf. Light at the longer near-infrared wavelengths can't be used by the plant, and so it will just pass through the leaf, and the leaf doesn't do much with it, or it gets reflected off. And so we can derive this CCI value, this chlorophyll concentration index or chlorophyll content index, as the ratio of transmission values at the near-infrared wavelengths and the red wavelength. And so in this example shown, we have a CCI value of about 7.5. And so this is a nice relative indication, but it's unitless. And one of the great advantages of this meter is that it will convert that unitless measure into a measure of absolute chlorophyll. And the way we do that is we follow a method outlined in this academic paper. In situ measurement of leaf chlorophyll concentration, analysis of the optical/absolute relationship. This was published by Christopher Perry, Mark Blomquist, Bruce Bugbee in 2014. And you can read it at your leisure if you'd like. In the paper, they correlate that CCI value to the quantity of chlorophyll in the leaf, which they derive using laboratory techniques. They do this for 22 or 23 different species, all of which have coefficients loaded onto our meter. Here's a brief look at the results of their paper. On the x-axis we have the CCI values, those unitless values. On the y-axis we have chlorophyll concentration measurements in absolute values of micromoles per meter squared. And so you can see that there's a positive relationship, but it's not perfectly linear. It's not a straight line. There's a little bit of a curve to it. And there's a little bit of difference depending on the species that you're using. Each of these different colored lines correlates to a different type of plant. And then on the bottom panel we have the curve for the general set of coefficients that you could use if you're studying a plant that is not included in this list. Here's another look at those type of curves. This comes out of our owner's manual, and we just show wheat, rice, and corn. Again, they're similar, but not precisely the same. So it's nice to have a curve particular to your species. Now this video is inspired by our new cannabis coefficients as well as grape coefficients. Here's a look at the new cannabis coefficients in green compared to wheat and the general set of coefficients, and you can see that cannabis has a different shape to it. For the same CCI value is on the x-axis down here and absolute chlorophyll on the y-axis. So for the same CCI value, it's about almost a 2 times difference, 1.8 times difference between cannabis and wheat. If you're looking at the same chlorophyll value, it's about a 2.5 times difference in CCI. And so this new set of coefficients will be great for our cannabis customers. So now we're at the part where I'll go over very quickly how to get those coefficients, load them onto your meter, select them, and take measurements. We will download the coefficients from our website. We will connect this to our computer using a little USB cord it came with. We'll drag the new files onto the folder that shows up from this MC100. We'll disconnect it, then we'll navigate to the coefficients on the screen here, and then you can start taking measurements. And it's just pushing down this arm with the leaf in between.